we're going to go ahead and get started. This is Final Boss Fights. If you just went to the EA talk, you now get to see what our game studio does at Take-Two. This talk is about how we launch games on Kubernetes, and I am joined by my fellow colleagues, if you'd like to introduce yourselves.
Hey folks, I'm Justin Schwartz. I am a senior architect with Zynga, and I am the co-lead of the Kubernetes team.
Hi, I'm Krunal Soni. I am part of the same team, senior architect, working with Justin and Molly.
And I'm Steve Phillips. I'm a technical account manager for AWS. I work in AWS's enterprise support organization.
So Steve is being modest. He has been working with us for 10 years at Zynga, which I don't know about you all, but if you've had the same representative from your vendor for 10 years, that is a miracle. So thank you, Steve.
Thank you, Steve.
Thanks for dating me, Molly.
If you don't know Zynga, Zynga is a wholly owned subsidiary of Take-Two Interactive. A lot of people have approached me at this conference and said, hey, I want to talk to you about Grand Theft Auto. I'm sorry, I don't work on Grand Theft Auto. We actually support over 70 mobile games in our division through various shared services, and we're gonna talk a little bit about that today. But to introduce those games, you may have heard of some of them: Words with Friends, Zynga Poker, Game of Thrones Legends, Merge Dragons. If you're old school Facebook, Farmville was one of our older games. Oh, wow, nice. Yeah, people were like, say some new games, and we've got actually Farmville games, friends in the back. Cool. CSR 2. I want to introduce a video from our Zynga ads team because we also have an entire publishing division just to kind of show the scope of what we run on Kubernetes, which is way more than games. So here's a video about us.
From the moment that I first laid eyes on you, got this good old feeling that felt like brand new. My head was summing up, running up the hype, my heart was drumming up, pumping up the vibes. I can read you like a book when you give me that look. Sailing right on through the skies. Yeah, I see the devil's face. Don't stir, just shake. Yeah, we gonna do it right. I just know you're gonna like it when I hit the countdown. I just know you're gonna dig it when the bass line bounce. We're gonna jam it when they start to yell. Yeah, you're gonna like it. I just know you're gonna like it. Yeah, I know you're gonna like it. Don't you worry now, you're gonna like it. The feeling is mutual, you know I like it too. Don't know what hit 'em now out of the blue. Everyone was lining up, climbing up to see it. They all rising up, shining up, can't believe it.
Who will you summon to fight for your house?
Yeah, I know. You're gonna like it.
So that's our company. You can now tell all your friends you saw Jon Snow at KubeCon, and you won't technically be lying. So let's start with what is Zynga mobile game tech, and what is a Kubernetes team?
Yeah, you bet. Thank you for that question. Hey folks, thank you very much for coming to our talk. It's a pleasure to be here with you. Zynga Mobile Game Tech is our central technology team within Zynga. We operate in a hub and spoke model. Games need common services such as identity, be able to store game state and objects. They need things like conversation and location and guilds. And so instead of having each game build all of these services separately, we have a central tech team that manages and develops these services. Similarly, as part of the infrastructure team, we provide both games and services with Kubernetes as a managed service, so they can concentrate on building features, fixing bugs, and delighting their game players, and leave all the dog work to us.
Nice. And Krunal, what does a typical launch timeline look like, and what activities do we cover that maybe is different structurally from other companies?
So launch timeline, that's an easy question. It depends. We have some hyper-casual games requiring as little as a few months, or we may have games that requires few years for development. As far as what we do during the development of game, that's a little bit long answer. So it starts with the onboarding a game. At the start of the game development, we decide what kind of cluster we're going to put the game on. Is it going to be a single tenant cluster or multi-tenant cluster? If it is a multi-tenant cluster, we look at what other workloads are running on that cluster. If the game application workloads are going to be running on the same node pool as some other application, then we'll take that into the account. Then at the beginning, we work with our customers to determine initial tuning. We work with them to determine things like pod priorities, pod disruption budgets, topology spread constraints, things of that nature. Now, we have our own standardization for certain things like pod priorities, so we want to make sure that the way they use kind of matches with how we have set up these things. The customer's knowledge of Kubernetes can vary significantly. Some game teams are quite an expert in Kubernetes, and some game teams are just looking to deploy their workload on an infrastructure, and they are looking for us to provide them their expertise. So we discuss those things initially. Now, initially, it's possible that some of this tuning that we do may not, some things may fall through the cracks. And so during the development time, you usually catch them either during our maintenance work as we are rotating the worker nodes and things like that, or if when the game teams will perform their performance testing, like load testing. Some of the example can be, if they have set up proper pod disruption budgets. If the pod disruption budget is not specified, or if it is not allowing any disruption whatsoever, then when we rotate the node, is going to stop the node training, right? So things like that we look into. Now, I mentioned load test. That is an important part during the development of the game. Load tests provide us, obviously, like making sure that the game is going to behave and scale according to what they are expecting. So when the game teams perform their load test on our cluster, we also watch out for those things. We pay attention to things like DNS usage. We pay attention to CPU and memory resource requirement as well as usage. We verify that any applications are not CPU throttle, or they are not out of memory errors, things of that nature. And on EC2 side, we verify things like is there any EC2 network bandwidth related usage, then EBS usage for disk, things like that. And then also during the load test, now we are an infrastructure team. We manage many clusters, and we have wide variety of customers deploying their workloads on our clusters. So we are definitely not expert on every applications being deployed on our clusters. So this is a good chance for us to understand their game workloads as well as the behavior for their applications. If in the future there are any issues that they are facing, having this knowledge help them. A lot of times customers come with us for the issues that may not have to do with infrastructure or add-on we manage. However, we still have to help them pinpoint where the issue is to solve that. For example, as you guys are aware, Kubernetes is complex and attack, and it got a lot of moving pieces, right? And so if you have, let's say, which is a common occurrence sometimes when you have a rare issue, if you have a pod having a network issue, it could be in a problem in a lot of places. It could be a cloud-related issue. It can be node hardware-related issue. It can be a cluster CNI, network policy-related issue. So there are a lot of even DNS, like node local DNS, core DNS, things that we use. So having this knowledge kind of help them during the debugging. And this is not the set in the stone process. We tweak our processes according to the game needs.
So we catch most things before we're even close to a worldwide launch on application configurations. And you were saying how many clusters we manage. We manage over 20 customer clusters, and we have over 220 Kubernetes users in the company. However, we still need AWS's help. Steve, can you tell us a little bit about what are y'all looking at when we're about to launch a game, and how do you get us ready?
Sure, sure. You're being modest. We don't do all that much, but as Zynga not only uses AWS services, but is an AWS enterprise support customer, they get certain entitlements like an assignment of a technical account manager like myself to their organization. And I, being part of the support organization, I help them with game launches through another entitlement called Countdown. Countdown is a process where we start working with teams like Zynga 4 to 6 weeks before their launch, a critical launch like a game launch or a migration. And we capture specifics about the launch, what's going to happen. We identify resources that are going to be used. And then we start looking at capacity and where scaling issues could happen. For example, service quotas, service limits. We make sure that the game that's launching has sufficient quotas in place to support peak capacity, peak player engagement for that game. In addition to service quotas, I think Justin mentioned, or Krunal mentioned, load testing. We work actively hand in hand with the Zynga team for load testing. So as they're executing their load tests, we're watching on the infrastructure side, we're monitoring, and we're looking for any, not just points of failure, but points of slowdown, potential issues, areas that we should focus on before game launch. And then next, we document all of this. So we build a shared, think of it as a shared run book for infrastructure and also for their game applications to prepare for launch. And then finally, when we get to that magic launch day, we have active monitoring going on. We have folks looking at dashboards and ensuring that the launch goes off without any issues.
We're always, even after we launch, still pushing updates and different amount of marketing, but obviously worldwide launch is really big, and a lot more marketing usually goes into that. So that's why we have to care quite a bit for turning on those lights. Justin, you mentioned too that we are more of the infrastructure team. One of our customers is the rest of our org, which is the platform engineering team, separated into divisions like core, tools, FinOps. If you go to our website on our jobs, you'll kind of be able to reverse engineer that a little bit. But can you tell us how they handle forecasting for their applications?
Absolutely, for sure. So a game is typically going to be in some kind of soft launch state. So they get an idea based on the region that they've launched in and their marketing forecast about how big they're going to be. They then enter a process with the core team to tell them, okay, based on all the services that we require, these are the levels that we're going to anticipate in terms of numbers of requests per second, per minute, daily averages. Those core teams then take a look at their current capacity to see, do they need to do anything? In some cases, they don't. Their current capacity, based on the size of the game, based on the metrics that they're seeing in soft launch, they may have nothing to do. But most likely, they're going to have to tweak some kind of configuration, whether that is their resource requests, their scaling parameters, and in rare cases, but it does happen, they may even need to make some code changes to accommodate an influx of high volume, high value requests that are coming in. That is done in a formalized process that takes place. The game has to submit these metrics to the core teams, allow them to do analysis and simulation to ensure that this uptick in requests can be handled by their current or forecasted configuration. And then once we go into actual launch, we see whether or not we got it right, which usually happens, but not always.
And some of y'all know we're close to the US holiday Thanksgiving right now. So we never wait until the last minute to do this type of forecasting. We always anticipate increased load and marketing around different holidays and events. So we're constantly talking to our teams. What about the cluster? And I like this question a lot because when we're talking to people, they're like, what if you blow up the cluster? I'm like, a cluster is a set of distributed components. What do you mean by blow up cluster?
We try to blow it up.
Krunal?
Yeah, so as Justin mentioned, we have these microservices, right? And they are also deployed on the clusters that we manage. So when it comes time to figure out if the cluster is ready to handle the expected forecast, we have to look at both clusters, the multi-tenant cluster that microservices are running on, and then the cluster that is running application game workloads. So for multi-tenant cluster in general, because these applications are supporting many games, a lot of times not much tuning is required. However, if a service is going to have a drastic change, then we kind of verify what we need to do on cluster end for configuration. As Justin mentioned, there is a forecast. The forecast may come in like metrics such as CCU, concurrent user. You can have, or in case of multiplayer matches, you can have concurrent matches that are being played, or in case of specific application, you can have requests per second and things like that. And so once we have forecasts, we need to correlate with the existing data we have. And as Justin pointed out, in the soft launch, we may have live game data. We are not fully on all region. We are not fully in production everywhere, but we still have a data for certain region. Or we have the load test that we performed earlier, right? So we again analyze some of these things. We look at the limiting factors on cluster size. So for node side, we look at node limiting factors, similar to some of the things I mentioned in my previous answer: EC2 bandwidth, resource usages, EBS usage, and things like that. We look at the cluster and add-on limiting factors, DNS usage. Do we need to tune any add-on resources that we manage, like core DNS, node local DNS, things like that. We look at the cloud-specific resources. Do we have enough IP reservation, prefixes, and things like that? And as Steve mentioned, AWS is there to help us out as well. If we are using things like load balancers, we reach out to AWS to pre-warm the load balancers so that we don't have cold start during the game launch. So those are some of the things we perform.
This kind of goes into the next question. You talked a bit about the fact that we're looking at IPs. It used to be retroactive. It's not retroactive now because we want to know when we're going to run out of IPs. Can you tell us a little bit more about what we monitor and how many things we monitor?
Yeah. So, purpose for monitoring for us is a few things. We want to verify, in general, we want to look at some dashboards and things like that and see if things are running healthy. We want to be alerted when things are having problems. And then we want to have a good monitoring solution to allow us to debug and analyze any issues that we may have been facing. A lot of times, as you know, Kubernetes things can easily go up and down, and we can be debugging issues that may not be happening live. So having a good monitoring solution allows us to find the solution for the issue later on. So we have a telemetry-based data that we use Datadog for, and then for logging, we use Splunk. Now, for monitors, we manage around 70 odd number of monitors. These are generic monitors applied for all customers. We categorize these monitors in different ways. So for any infrastructure resource related monitors, imagine things like, as Molly mentioned, IP is going down, available IP is going down, or things like disk usage is reaching the threshold on a node. Those are infrastructure monitors. So we are tagged as an owner for those monitors. For any Kubernetes application and controllers, anything that we manage, those are also being tagged as us as owners. And then everything else is customer workload. So in that case, we have a system, but in the end, those resources are tagged with customers as their owners. And the reason for this is that if there is an alert, let's say there is an infrastructure alert, then the escalation policy will be determined by the ownership of those alerts. So we will get any infrastructure or add-on that we manage. And if the customer is having issues like their pod not being ready and things like that, then they will directly go to their escalation policy. In that case, we won't be involved in direct on-call process unless we are explicitly called by the customers to help them out. As far as the dashboard goes, we have a Datadog dashboards, and we monitor things like we have one monitor which is covering all the cluster as a single place. That's the aggregation. That allows us to kind of look at system level issues we may be having or system level health. Imagine like some zone in AWS having issue. Those things will easily show up on that. We have cluster-specific monitor. We have pod, container, and application level monitors. They are, sorry, not monitor, dashboards. They are designed for looking at the health at that granularity. We have add-on specific dashboards. Things like Carpenter, AWS load balancer controller, things of that nature. And then we got node level dashboard as well that allows us to look at metrics for individual nodes. As far as the metrics are concerned, a lot of the metrics are available right away from Datadog for many things, but there are times that we may have to create our own custom metrics to monitor things. A few examples are core DNS and non-local DNS monitoring. We run a cron job to verify that the DNS is working on every node frequently, and if not, then we get alerted. As far as the logging goes, we got Splunk, and we got a bunch of Splunk dashboards. I will just quickly go over a few. We have filtering capabilities. I mentioned debugging. So we got a pod and node audit dashboard that allow us to look at the life cycle of pod and node from the start to finish. We collect control plane logs. We have a system level logs, as well as we have a CloudTrail logs. And so we have another like add-on based dashboard as well, like AWS load balancer controller. It allows us to not only look at when a particular pod is being deleted from the controller perspective, when is sending AWS API request to update the target group, and we can actually see those things in the CloudTrail, and then we can also verify exactly when change is happening. There are a few more dashboards, but in general, I think I covered a lot.
Krunal is our de facto Datadog expert, and if he didn't work for Zynga, he would almost certainly work for Datadog. So you can hit him up after if you have any questions and you don't want to go downstairs. Steve, though, we can hit problems. I actually haven't seen any problems in a worldwide launch, which is super boring. one time in a job, had to spin up 800 servers and got called by concierge, and that's never happened to me at Zynga. But if that did happen, what do we do when we're in an incident?
Yeah.
During worldwide launch?
Yeah, so thinking about game launches and issues that have happened, we've been very fortunate with Zynga and across the Take-Two organization. We've caught issues before, but I can't recall any actually happening. But if they did, back to the countdown process. So we've already established lines of communication, dedicated channels like Slack channels, and depending on the launch, we may be in a virtual conference room with the Zynga team during their game launch. We go from planning before the launch window opens to active mode once the game launches. And at that time, we're actively engaged. We're giving our observations to the Zynga team over Slack or in a virtual conference room. We're letting them know what we see on the infrastructure side, what we're seeing on the dashboards that we're looking at. In the event that something like a scaling issue happens, we have multiple tiers of support. The initial point of contact is to create a case via phone or chat, and that gets support engaged immediately. For Zynga, being an enterprise support customer and having a technical account manager team available, we also get paged for critical alert cases are submitted. And then we immediately get involved and we work our channels to ensure that the right folks are engaged in working any issues that may come up. And then finally, during the launch window, we're doing all of the same until that launch window closes and any issues have been resolved.
So we have had incidents. Everybody has incidents. We just haven't seen them during.
What do you mean?
We're
Sorry.
perfect. Everybody has something, even though we don't have them during worldwide launches. Gonna list a hypothetical. For example, if you hit a bug and spin up 500 servers and FinOps tells you you're about to spend $400,000 more a year, what does that look like in our team?
Yeah, thank you for that. We operate in a shared responsibility model, and we have a dedicated SRE team that is our first line of response for issues that get triggered via the Datadog PagerDuty pipeline. Depending on the severity of the issue, we might actually declare an incident, and that usually takes place when multiple systems go down or there's revenue impact. And when that takes place, we have a very clear playbook that dictates how to operate an incident. It opens up additional resources. We assign specific roles to individuals to manage the incident, to communicate what's happening. We have a strict policy to update all the stakeholders every 15 minutes as to what is taking place. And usually we get pulled into an incident if it has anything to do with Kubernetes or cloud or anything adjacent.
I like that he mentioned that because a lot of times it is something we have as a single pane of glass to help people with, but not an actual thing we caused. So we get pulled into a lot of things, and we're basically the consultants. So we only have 2 minutes left. So I don't know if y'all know this, but it's all of our first times at KubeCon, and 2 of us are Atlanta locals, so thank you so much for hosting this in Atlanta. Please do that again. Next year it's in Salt Lake City, so boom, boom. Can each of you list your favorite thing about KubeCon? Starting with Justin.
Yeah, I'll go first. In my daily life, most people that I know have absolutely no idea what I do or don't understand anything I'm talking about, so it's really nice to be surrounded by thousands of people who get me.
For me, AI is everywhere, and rather than understanding how to deploy the AI workloads on Kubernetes cluster, I was interested in learning how to operate things better with AI. So there were some interesting talks about AI ops, so that was pretty good.
Steve?
Let's see. The auto mode beanie at the AWS booth? No? No, seriously, the sticker booth had to be the coolest thing ever. I've stocked up on my stickers.
I didn't expect this, but my dog passed away last week, and Justin was like, hey, you can pet puppies at KubeCon. And I was like, what? So that's definitely my favorite thing. So yeah, whoever's ever idea for that, I owe you a beer. Thank you so much. So we will be around, because we have 3 seconds left. We'll be out there. You can come talk to us, ask any questions. Thank you.
Thank you.